Hi guys, in the last few videos we looked into linear expansion and factorization. So as we've seen previously, a linear expansion is when you have an algebraic term and you multiply that by a bracket. And we've done many problems in this area. Just to recap, let me do a question. So 2x times 3x plus 2. Now if you take this as an example, the way you expand this is that you multiply both 3x and 2 by the outside term, in this case 2x. So 2x times 3x is 2 times 3 is 6, x times x is x squared, 6x squared, and 2x times 2 is 4x. Now this is how you expand linearly. So when you have a term and a bracket multiplying together, we call that a linear expansion. In today's video, we'll be looking into binomial expansion. Let me write that down. Binomial expansion. Now, what is binomial expansion? It is when two brackets are multiplying by each other. Now, in this case, we don't have a term and a bracket multiplying. We have directly two brackets multiplying by each other. For example, x plus 5 multiplying with x plus 2, or 2x minus 3 multiplying with x plus 4, and so on. So as you can see, in this case we have two separate brackets multiplying with each other, and let's see how we can expand binomial expansions. So let's start with an example. So we'll take this example, x plus 5 times x minus 2. I'm going to do this in two different methods. So let's start our first method. So the first method is all about multiplying each term by the other term. So the way I'm going to start this is I'm going to take the first term of the first bracket and I'm going to multiply both the terms from the second bracket. So x times x times minus 2. So let's write that down first. X times x is x squared, x times minus 2 is minus 2x. And then I'm going to go to the next term, which is plus 5, and I'm going to do the same. I'm going to multiply this plus 5 with both the terms in the next bracket. So 5 times x and 5 times negative 2. So 5 times x is positive 5x, and 5 times negative 2 is negative 10. Now usually when you expand binomial expansions, you will get four terms like this. So if you notice here, we have four individual algebraic terms: x squared minus 2x plus 5x minus 10. But then we can simplify this. If you observe, the second term and the third term are both like terms. They both have the same variable x. So we can simplify that by adding them together. So minus 2x plus 5x is plus 3x. So x squared plus 3x minus 10. Now there is something special about this answer over here, because this answer is called a quadratic expression. A quadratic expression is any expression of the format ax squared plus bx plus c. What this means is that you will have an x squared term at the beginning, and x term, and then just a number, constant c. Now not all binomial expansion end with a quadratic expression. However, most of them would. Now we will look into these quadratic expressions more in the future videos, but at the moment just understand that a binomial expansion will often end in a quadratic expression. Right, now let's look at the second method. Now the second method that I'm talking about is not actually a method by itself, it's just a more elaborate way of writing the same first method. Now let me show what I mean by that. So again, what we're going to do is we're going to multiply each term, but this time it's going to be a little different. That is, we're going to take the first term x. Instead of multiplying them individually, we're going to multiply the entire bracket here. So x times the entire bracket. So that's x times x minus 2. Right? And then we're going to do the same thing for the second term, so that we have plus 5 here, and the plus 5 will be multiplied by the second bracket. So plus 5 times the entire second bracket, x minus 2. So what we've actually done here is we've broken down the binomial expansion into two individual linear expansions. So if you see here, this is a term multiplying a bracket, a term multiplying a bracket. So what we've done here is we've converted the binomial expansion into individual linear expansions, and we know how to do linear expansions. So let's go ahead and expand the linear expansions. X times x, right? So the way we do that is x times x, x times minus 2. So x times x is x squared, x times minus 2 is minus 2x. And then we have plus 5 times x. So plus 5 times x is plus 5x, and 5 times minus 2 is negative 10. Now if you see here, this is the same answer that we got over here. So this is the exact same answer as we have there. But the only difference is we have got an extra step. What we were doing in method 1 was also essentially the same thing, x times x and x times minus 2. But in this case, what we've done is we've just wrote it down in a separate step, and then we've made that multiplications. So it's just an extra step there, but more or less it's the same method. So then you might ask, why is that even a method? Why is that even called a method 2 when it's just method 1 in a more elaborate approach? Well, the reason why I wrote it down as a method 2 is because this method is going to be very, very, very important. Not just this method. What I mean by this method is this extra step here is going to be very important when it comes to factorizing quadratic expressions. Now, why is it important will be discussed in the next few videos, where we discuss about quadratic expression and factorizing them. But at the moment, just understand that this extra step is an important step for you to clearly understand what's going on in the factorization. Okay, so that's the reason I brought this extra step into as a second method, just for you to show that it's the same thing that's going on. So just to finish it off with the answer, x squared minus 2x plus 5x is plus 3x minus 10. So we end up with the same quadratic expression. Now, as I mentioned previously, this method is going to be useful in the future videos, not to directly use this method itself, but this method is going to be a reference for us in the future videos. Right, now let's look at a couple more questions. So let's do these two questions now. So for these two questions, I'll only be using method 1 because it's the same method actually. So let's go ahead. So 2x will be multiplied with x and with plus 3. So 2x times x is 2x squared. 2x times positive 3 is positive 6x. And then negative 5 times x and times 3. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. Now, as you can see, we have two middle terms, the second term and the third term. They both have the same variables, so they are like terms. So plus 6x minus 5x is just plus x. So the answer is 2x squared plus x minus 15. Again, what we've ended up with is a quadratic expression where the first term is an x squared, then we have an x term, then we have a constant c, or a constant number. Now let's look at the next question, the last question of this video. And if you notice that question, there is something different in that question. If you observe very carefully, you see two variables there. So you see x and y within the same binomial expansion, which we did not come across in the previous questions. So in the second question, we only have x in both the brackets. The first question also, we had only x in both the brackets. So question 3 has two variables. Now, would that make any difference in the way we do the question? Absolutely not. It's the same method. So we take 3x and multiply both 4 and 3y. 3x times 4 is 12x. 3x times 3y is 9xy. And then we have plus 2 times 4 and times 3y. Plus 2 times 4 is plus 8. Plus 2 times 3y is plus 6y. Now, the only difference with this third question is that you will not end up with a quadratic expression. If you see the previous two questions, you might have noticed that we were able to add middle two terms, the second term and the third term, to make it one term. You were able to add them because they were like terms. But in this question, you observe that there are no such like terms. So the answer for this question is that itself. That is the answer. So it's just 12x plus 9xy, and I'll just bring 6y at the beginning and then plus 8 at the end. That's just because of we used to write always the number at the end. So nothing wrong about writing this way. It's just we just rearrange in a way that the number comes at the end always. So this is the answer. Now we can't simplify it any further, as I mentioned earlier, because of not having any like terms. The first term is an x term, second term is an xy term, third term is a y term, and fourth term is just a constant. So we can't add anything here to make it simpler. So therefore, this does not end with a quadratic expression. So as I mentioned earlier, not all binomial expansion would end in a quadratic expression. That is not necessarily the case always, because as you see in the third example, there can be binomial expansions which will not end up in a quadratic expression. So that's it for today's video. I hope you guys understood and enjoyed this video. If you did, hit the like button and subscribe for more videos. And please feel free to comment below if you have any questions or if you have any topics that you want me to discuss in the future videos. See you in the next one.